CORS is an abbreviation for Cross-Origin Resource Sharing. On an intuitive level, if we see the meaning of the abbreviation Cross-Origin Resource Sharing, we can quickly understand that this is a definition related to some sort of resource sharing between origins. And that would be obviously the very correct educational guess just by looking at the name of the definition. Since its inception, CORS has become an integral part of how domains and web servers, web applications interact with each other in order to support each other and provide better experience for us users. On a more simpler level, there are two types of websites, two types of web applications: same origin and cross origin. Same origin applications or websites have all resources that the application needs on the same web server. For example, you're accessing your bank application, and the bank application has the resources, has the backend database, everything embedded into its own web page, whether it's an HTML web page, whether it's written in any other language from HTML or it's JavaScript, etc. We're not interested in that, but it's their own resource that is on their own web server. They don't need to interact with any other web servers in order to get the information that they need. However, in the example that you will see on the screen, you can see that some of the websites take advantage of embedding the resources from other websites into their website. Here in front of us, we have a US-based real estate website where you can see the announcements, the advertisements for different real estates. Say I want to look up a real estate in Texas state of the US. You can see that the real estates are displayed on a nice map of the state so that I know where is where exactly. If I try to look up the packages, inspect the page where everything is coming from and go to network, let me reload the page just in case. You can see that we have the main page and we have different components of the page. The components of the page that pertain to the map that we're seeing on the page actually are requested from a different URL that is different from the Zillow. So we are now at the Zillow website and they are requested from mapsgoogleapis.com, meaning that Zillow website has embedded Google Maps into its website in order not to come up and reinvent the wheel and come up with a different map and etc. They just used Google Maps in order to make it faster. One of the main advantages, of course, they're using cross-origin requests in order to embed Google Maps into their website and make it easier for customers or any other people to navigate through their website and see each advertisement on the map. As you have seen from the example, the real estate agent is using Google Maps in order to show the real estate advertisements that it's trying to show to its customers. And it didn't reinvent the wheel, it didn't have to come up with another map, it just used Google Maps. Right? It's using Google Maps through Google Maps API. They could have used any other maps, by the way. They could have used Apple Maps as well. It would still be a cross-origin. So in cross-origin, one web page is accessing the resources of the other web page in order to provide better experience, better information to the users, to people who are visiting and using that web application. Sometimes on different websites, it can be recipe websites or like language learning websites. You can see YouTube videos embedded into the website. So for example, you're scrolling through the website and there is a YouTube video in the middle and you can just click play and watch that YouTube video. Although you're not on the YouTube's website, you're just seeing a YouTube video. And that's also another example how the cross-origin course works basically. They're fetching the YouTube video, the resource, from YouTube and sharing it on their website. So let's see in more detail why we need cross-origin resource sharing. Of course, the first selling point for it is interaction. We need it for better interaction between websites, so that there is no need for a web application to record and post another video if there is already video for YouTube. So it basically eliminates overhead. No overhead. Overhead of resources and overhead overall eliminates the need to reinvent the wheel. Second selling point is the restricted resources. Some of the web pages just simply don't have the resources to have everything that their customers, their visitors need on their web page. They just can't have it. They don't have the capacity, they don't have the financial capacity to finance, let's say, creation a new map application. So they don't need it. So they are restricted within the resources. And in order to avoid this, they're using the cross origin, the resources of other origin, in order to come up with something that they need. And the third reason why it's important, the cross-origin resource sharing, is security. Sometimes users might not be able to access the resource on the real origin, but they can access the resource on the cross-origin. These are more complicated use cases, of course, but if you don't want to expose your public origin, your public server for the users, you can still share your resources with other origins so that other origin can represent your resources on your behalf. How do we know whether the web page that we are accessing supports CORS or not? Because what if we don't want, for security considerations, we don't want to visit a web page that is supporting CORS, that has some cross-origin resources. Our company might be against it, or for security considerations, as I mentioned. When you visit example.com, you want to make sure that you only see the resources of example.com. You don't want to see maps.google.com's resources on example.com. That's what you want. One of the ways to understand whether there is a cross-sharing CORS involved or not is called pre-flight requests. Whenever we are sending the request to a web server, you can see exactly how HTTP works in one of my videos related to HTTP. In order to understand whether CORS is supported, we send pre-flight request. Pre-flight request is a request without the real content, and it's request that uses options HTTP method. Let me remind you that we have different HTTP methods that we're using to communicate. It can be GET, it can be POST, and one of them is options. Options HTTP request is just used, as I said, as a pre-flight request to understand whether CORS is supported or not. And in the response, we get basically our response. And now we know whether CORS is supported or not. Some organizations or the web application firewalls can be set to work in a way that they prevent us from accessing the cross-origin resources. So for example, we can open the example.com webpage and our administrator doesn't want us to access the cross-origin resources shared on the webpage. And on the webpage, instead of a YouTube video, we can just see the broken puzzle. I'm sure many of you might have seen it at one point in your life. Meaning that we don't see what the page is trying to show us. That's how we're preventing from seeing it. Or we can be prevented from accessing the web page altogether. So, for example, if example.com supports CORS, we can't access it. That's how security policy works. There are a couple of ways for web developers to know how to integrate CORS. Of course, this video will not go into detail on how we integrate the CORS functionality into a web application, but I just wanted to mention that they might have to do changes in their web application code in order for the application to support CORS. At the moment, CORS is supported on different platforms with different programming languages. They include Express.js or Node.js, Django, underlying Python, Spring Boot, or Nginx. If your application is using one of these application servers, then you will be able to make changes and make sure that CORS is supported on your application. And the real question is that how do we, mere mortals, see how CORS works? How do we see it in essence, basically? So imagine we're trying to inspect the page, how I did earlier in the video. And how do I see what I'm exactly getting through CORS and what is allowed, what is not allowed? Because it sounds rather wide. Okay, cross-origin sharing. How much exactly do I share with another origin? Do my authentication credentials are shared too, or do they not? These questions can be answered by looking at the headers that pertain to CORS specifically. These headers all start with access control, access-control-something. So whenever you see access-control-something, these are the headers pertaining to CORS. However, don't be confused. If access control allow origin is set to something negative, it means that CORS is not supported. So if you just see this header, and it's set to negative, please look at the screen for the exact values that you need to see when it's negative. Then CORS is not supported. However, if CORS is supported, there can be additional headers that come with CORS in order to regulate how it works. So you can see access control allow origin, access control. It's being repeated, that's why I didn't write it several times. Access control allow methods, access control allow headers, access control allow credentials, access control expose headers, and access control max age. So intuitively you can see that the allow methods and allow headers are the list of methods and headers that are allowed within CORS. So for example, we can prevent from post being allowed, right? In order for better security, or we think that it's just not necessary, because CORS can be used by bad actors, by malicious users, in order to stage their cybersecurity attacks. So it's not as safe as it can be seen. That's why some administrators might allow CORS but restrict the number of methods. So for example, they could use get but could not use post. Allow headers, these are the list of allowed headers. Allow credentials. This defines whether credentials can be shared with the cross-origin server. The credentials passed by the user to the first server, which is example.com. Imagine you're accessing example.com. This is our destination A. And example.com has resources of maps.com, let's say, which is destination B. So if destination A can share credentials with destination B within CORS, and that's how we define it in access control allow credentials header in our CORS request. And access control max age, remember, max age is always related to the age of the, not always, but most commonly is related to the age of the cookies. So max age defines the age of the cookies that are passed to cross-origin server. So how long should it save the cookies and when they should be purged. Although CORS has become a real thing lately, and almost all browsers support it, be it Firefox, Safari has better security considerations about CORS, Chrome, and many others. It's still not as secure as we would like it to be, and many web applications should take extra steps in order to protect themselves from the security gaps that CORS introduces into their infrastructure. So for example, we have talked in one of my previous videos about APIs, and CORS can expose some of our APIs, or it can expose the APIs of destination B, the cross-origin, right? Some of the APIs that are not listed can be unintentionally exposed while the origins are shared, and this is something neither the original origin nor the cross-origin wants. Second problem is the practical challenges. Remember that to ourselves we can think that, wow, this is a piece of cake. I will just integrate different details from different origins and that will work. However, in reality, there can be some compatibility issues. For example, when the web pages, the original origin and cross-origin are written in different languages, they are written in different formats, they have incompatible versions of servers, and there are so many different compatibility issues that need to be resolved for CORS to work successfully. What I'm trying to say is that it's not as easy as it seems. It's not just a piece of cake. The people who are behind the web applications, behind the design of web applications, need to pay extra attention to details in order to make this interaction work. The third problem is on unauthorized access. This is a very important point to consider. Imagine the cross origin has the restricted access. It has some details that need not to be shared with the general public. A good example is the state database of the points that we might have on our driving license. For example, you're trying to buy a new insurance for your car, and to buy a new insurance, they need to check points on your license. And they send APIs to the state cross-origin server in order to show the number of points that you have on your license and decide whether you should get the insurance or not. However, unintentionally, that original origin can be in breach of the data privacy regulations. It can be in breach, it can access some data that it's not supposed to access. Recently, there has been a spread of news about hospitals sharing news of some of their celebrity patients with the media to make more money. Some hospital staff probably shares some health-related issue of a celebrity and they make money of it. And this is a similar issue. So during CORS, the operation of CORS, they can unintentionally access the resources they're not supposed to access. And that can create obviously additional problems with data privacy and unauthorized access. This was a general view of the course. Please, in the comment section down below, let me know what you think about this topic. Have you ever come across CORS? And if you have, in what context? Also, don't forget to mention which another topic you would like me to make a video on. Have a nice day. Bye!